G'day, Lockie here. Today we're going to unbox Kubeflow. So on stage at KubeCon last week, David Aranchik was up talking about Kubeflow. So what I wanted to do was go through Kubeflow and show you quite literally the value that it adds. Now, if you haven't actually heard of Kubeflow before, go check out that keynote that David did at KubeCon. But Kubeflow was announced back in Austin, KubeCon, late last year, and it's around creating a machine learning toolkit for Kubernetes. So it's becoming increasingly popular for folks to start to use Kubernetes to run distributed machine learning, training, and serving on top of Kubernetes. So the endeavor behind Kubeflow is to have a great space to actually collaborate on building a toolkit that's pluggable and portable and scalable. So I want to go through very practically how Kubeflow can actually help you, whether you're a data scientist or an infrastructure engineer, and give you a little understanding of what's under the hood. Now, if you go to github.com Kubeflow, all the information is in here on how to install it. I've taken a couple of steps shortcut here, but you can follow along from home. The other thing is we do actually allow you to provision GPU hardware, so GPU-backed VMs on AKS, on Azure, and I'll be using an AKS cluster to do this. So if you go and look for the AKS docs using GPUs on AKS. One other thing that we've done is actually we've created a set of labs as well, so you can follow through with everything I'm going to show today, and we step through all the value props, so starting from building a training model training on a Docker daemon locally, to pushing that out into distributed TensorFlow or hyperparameter sweeps and serving. So I will kind of shortcut through some of these things just in the interest of time, but I think it'll be fun to actually show you what we have. So what I'm going to do is just pop over to my cluster here. So here I have AKS cluster with, I believe, 8 nodes, 8 GPU enabled nodes. Okay, so they're up and running on 196. What I have in this top half of the screen here is I actually have the demos set up so that I can run a demo script and actually go through. So what I'm going to do here down the bottom is do kubectl get pods. I'm going to put a watch on that. So at the moment, there's nothing but a Minio pod actually running in the default namespace. And actually, before I go on, I will show you Kubeflow has been installed as well. So there's a step in that document on how to do it. So Kubeflow is up and running here. We have a few things running in the Kubeflow namespace. We have Ambassador, so that's all about having a unified ingress for data scientists to access. And here we have Jupyter Hub up and running. We can spit out multiple Jupyter Notebook services from there. We also have the TF job operator, which I'll go through as well. So first of all, I'm going to pop over to VS Code and just show you what we got here. So I'm going to go through TF job. Now, what TF job aims to do is create a custom, it's a custom kind, so we're talking about custom resources in Kubernetes, and it takes away all the complexity in mapping TensorFlow jobs onto Kubernetes resources. So the operator will actually take and process this custom resource and do things like actually mount the drivers and libraries in the right place. So with specialized GPU hardware, we have devices and they have drivers that actually need to be mounted. We can abstract that away. So this is a very lightweight TensorFlow MNIST workflow on GPUs. We're telling it the resources we need, in this case 1 GPU, and we're actually using Azure File to go and store the training data. Okay, so I'm going to go ahead and run this in the demo. So what we're going to do is actually get a list of nodes and how many GPUs they have. We should, yep, so we have 8 nodes, they all have a single GPU. Now we're going to go ahead and create that custom resource, that custom TF job. The TF operator is actually going to pick that up and create a job here. We can see that's in running state. Now if I go and just grab the logs on that. Okay, so we can see this is picked up. We have a Tesla K80 GPU here. Now it's actually going to perform the training once it spins up here and loads the data in. So what we've got there is a very lightweight custom abstraction on top of Kubernetes that can interpret that resource and create it into a set of resources needed by TensorFlow to constitute a job in the means of TensorFlow. Now this individual training is not too much different to a Kubernetes job run to complete, but when I go into the next phase here, you'll actually be able to see some more value here. So single job there. We're going to go to distributed TensorFlow now. So what we're going to do, I'm actually going to pop back here to this lab that we've created. So here's distributed TensorFlow. The great thing about these labs is they're self-paced and you can actually get some background information. But in the model of a distributed TensorFlow job, you actually have a parameter server, master, and worker nodes. Now, in the case that you try and set this up on Kubernetes without TF job, you would be responsible for telling all the parameter servers, workers, and masters about each and every other pod IP, and they all need to connect to one another. Now, obviously, this isn't very scalable. What TF job will do is actually take care of that on your behalf. So what we have here in distributed TensorFlow, I'm going to close this one from before. We actually have a model here. Now, the interesting thing about this one is we have replica type, worker, replicas 1. Depends on how many GPUs you have here. How many workers do we want? Okay, so we have a parameter server, we have a worker, and we have a master here. So we have the three things, and they're all modeled in this TF job. So the TF operator will actually go and lay all those resources down and spin this up for us. Okay, so I was watching this training there. Okay, so I'm going to go ahead and delete. Okay, fantastic. Now I'm going to move on to 07 distributed TensorFlow. We're going to kick this demo off. We're going to create that resource. Okay, what we should see is if I do a watch, we see, okay, we have a master, we have a parameter server, we have a worker. They're all up and running. We're using Azure File under the hood. So let me go and just take a look. I have the Storage Explorer here. Okay, so let me refresh this. Okay, so we have the module 6.1 that we did before. Here's the input data and the logs. Let's go back up. This is the training that I'm performing now, and I have this one laying around before. I'm going to just delete this. Okay, so it is actually written out onto Azure File. That means what we can actually do while this is running, we can actually create a tensor board, and with TensorBoard we can actually introspect what that training is actually doing at any given point. So I'm going to create a port forward because I do not have this pod exposed externally. Port 6006 is what it listens on. Okay, now I'll hop back to my browser. Localhost, okay, 6006. Here's a TensorBoard. That's actually going to read the data out of Azure File, the training data, and we can actually introspect the test and the train runs that we have here and exactly the accuracy, our model, the entropy, biases, anything like that. So everything is in the TensorBoard from that distributed TensorFlow run, which is fantastic. Okay. What I'm going to do now is actually move on to, so we'll clean up from that one. Okay. That should go, okay. So what we're going to do now is actually move on to hyperparameter sweep. So one of the things you want to do is actually, as a data scientist, run different hyperparameters to actually find out which set of hyperparameters make your model run the best and give you the best outcome. So here we have an example of how we're going to do that here. So in this model, we have these hyperparameter values, some learning rates, and some hidden layers. So what we're going to do is actually create, in parallel, a hyperparameter sweep and actually look at a TensorBoard to see which one of these hyperparameters is making our model produce the most accurate results. So here we have a model based here, and we're going to basically give it an input of an image, and the model should try to endeavor to recreate this image from this source. Okay, so what we have here is we've actually gone ahead and packaged this up as a Helm chart, and I'll show you how it runs. But this is great for a data scientist. They create these models, they want to train them, and obviously being able to train doing a hyperparameter sweep allows them to get the best visibility into what hyperparameters and isolate different variants there and how they perform. Okay, so I'm going to pop over here to hyperparameter sweep. I will start up my watch down here. And we're going to run the demo again. So we're actually going to install a Helm chart that's going to give us all these different hyperparameters and all the matrices of them. They're all TF jobs again. Those TF jobs are going to spin up, and we also have a TensorBoard here that's on a load balancer. So these jobs are actually running up now. So I'm going to grab this TensorBoard rather than wait for the public IP, kubectl port forward. Okay. Again, hit the TensorBoard because I want to be able to see. I will refresh this. All right, so here are all our, you can see we have different learning rates and different hidden layers here. So learning rate 0.1 and 6 hidden layers that we have, test and train for each, and these are all going through right now. So what we should be able to see is, hey, look at learning rate 0.01, hidden layers of 6. We're not actually producing anything that looks like Vincent van Gogh's work of Starry Night, but here we're actually seeing something that may be more reasonable, so we can do this. And in later versions of Tensorflow, you can actually go and prune things that aren't producing the results that you want. So let's continue to watch this. But what we have here, this would have been extremely complex for me to actually program and put on a Kubernetes, but we've given a very lightweight way and a simple custom resource to actually go and do this hyperparameter training sweep. So we're getting something here. This set of hyperparameters is actually yielding a little bit better result. Still not terribly visible, but it will continue to train and we should see some better results. Now, while we're doing that, I'm just going to pop over here and do a kubectl get service in the namespace Kubeflow, almost. Now, I mentioned we have a Jupyter Hub set up here. So what we can do is, while data scientists want to actually develop their models, they want to collaborate on their models. So we actually have, let me log out here, we have Jupyter Hub up and running. So I could create test, create a new user here called test. We could spin them up a Jupyter notebook for their individual use. So let's go ahead and I'll set up some requirements here, resource requirements, and GPU. Okay, sure. So this will actually spawn a Jupyter notebook. So if we pop back over here and do a kubectl get pods in the namespace Kubeflow, we should see that there is a Jupyter notebook called test being spun up. And because I put the requirement of that resource on it, it's impending because my my sweep, hyperparameter sweep, is still running, and that's actually using all the GPUs I have available. So let's just let this, so you can see here we're getting closer to Vincent van Gogh's model, so you can see that maybe this is a run we want to continue to train. This set of hyperparameters is actually better to produce the target outcome that we want for this model. Okay, so that's sweeping. I'm going to just clean up from that. That was installed with Helm. Okay, Helm delete. I'm going to delete that. Torrid Cricket. That'll kubectl get pods. Okay, so that's actually being removed now, and we should see that Jupyter notebook. So we should have a space. This should go from pending to running eventually once we free up some space on some of those GPUs, because I put that as a requirement there. So you have a collaborative space with Jupyter Hub to be able to create Jupyter notebooks and have data scientists collaborate on models that they're building there. So again, very easy to get Jupyter notebooks spun up on Kubernetes. Great, very lightweight outcome. Okay, so this is still waiting for that to come up. That's no problems here. Now finally, so we've looked at training, model development. So training we were doing just then, model development in Jupyter Hub and Jupyter Notebooks, and now let's go and take a look at serving. So finally over here, what we're going to do is, if I just go back, I'm going to look at serving. What we're going to do is just serve a pre-trained MNIST model. So we're going to actually have an endpoint that we can actually shoot images into, and the model will actually detect what number I'm sending in. So what I'm going to do here is, if we take a look at what we've had here a little earlier, kubectl get pods in the serving namespace. So I've already pre-deployed this model. It's been pre-trained. You can follow along. But what we should have is, if I export it, we can export an image file, and I will export the public IP that this model is exposed on, and I should be able to just run Python m nistclient.py here. So what I'm going to do here is shoot in an image of the number 1 into this endpoint, and we're serving it using TensorFlow serving on top of Kubeflow. Okay, so I should be able to pass in this. It should be able to say, okay, here's the results coming back. Okay, so I have, that is the number 1. Okay, fantastic. Let's go and prove that this wasn't pre-canned. Lucky number 9. Okay, and it just detected that as 9. So there are 3 different things I have showed. I've showed model development with Jupyter Hub, Jupyter Notebooks, training using TF-Job for TensorFlow-based, framework-based models, and serving, so TensorFlow serving. Now, this is all very pluggable. That is not all Kubeflow can do. If you go and take a look, Kubeflow is actually installed with Case on it, and there are all these other modules, Selden Core, PyTorch Job, Argo. So I encourage you to go and take a look. If you're in this space, come and take a look at what we're building here. It's a great way to get engaged and to try and help make data scientists be more enabled and less worried about how Kubernetes is running and actually building and training models on a platform. So hopefully that gives you an overview of everything. Okay, this Jupyter notebook is actually up and running, as I said, so we can start a Python 2 notebook. So just to finish that out. But hopefully that gives you an overview of the power of the toolkit that we're building in Kubeflow. And if you want to kick the tires, you can actually go, we have these labs upstream. If you go to GitHub, Azure, Kubeflow labs, you can actually walk through these at your own pace and actually create all the demos I just showed in this video. So I'm really excited about this project and excited how accessible it's going to make data science and distributed TensorFlow and other frameworks, machine learning frameworks on Kubernetes. So thanks for joining. If you enjoyed this video, please subscribe. I try and produce videos every week or so. So thanks for joining. Cheers. Bye.